All right. Today we're going to start talking about section 2.2 here. But to begin, I just want to get you guys thinking about slope a little bit. Obviously, with a video, we're not going to be able to have the same conversation that we would if I was in class. But think about slope. Right away, everybody's kind of most basic definition of it is going to be your rise over your run. And really what that means is you're looking at the steepness or the angle that your graph either rises or falls. So maybe it goes up really quick, or it falls really slow. Either one, you're talking about that slope. A lot of people go to the equation y equals mx plus b because that m still stands for your slope. And hopefully you guys remember from algebra 1 and algebra 2 your slope equation: y sub 2 minus y sub 1 over x sub 2 minus x sub 1. This should be something that you guys remember. You work with it quite a bit in algebra 1 and you use it a lot in algebra 2 as well. So it's kind of one of the big concepts of algebra that you're going to need to remember. So today we're going to go over 2.2, slopes and equations of lines. That's kind of why I wanted to get you guys thinking about slope here. So right away we're going to talk about slope. The slope of a non-vertical segment, meaning it's not going straight up and down. That slope is undefined. Of some segment, P sub 1 and P sub 2, where you have your two endpoints, then your slope is going to be your slope formula: y sub 2 minus y sub 1 divided by x sub 2 minus x sub 1. So you guys have used this quite a bit here. If we take a look at the slope of these segments, we can find the slope of q sub 1 and q sub 2. So if I look at q sub 1, okay, I know I'm going to need to use my slope formula: y sub 2 minus y sub 1 divided by x sub 2 minus x sub 1. So if I look at q sub 1 and q sub 2, that will be that line segment. Okay, what I like to do with these is actually label my points x sub 1, x sub 2, y sub 1, y sub 2. So for no real reason, since I already have 1s and 2s in my picture, I've got my p sub 1, p sub 2, q sub 1, q sub 2. I'm going to call this my x sub 2 and my y sub 2, and this is going to be my x sub 1 and my y sub 1. You don't have to do this. It's just one thing that I've found throughout the years that it really helps keep things straight, so that I make sure that I plug everything into the right place after this equation is over. So then once I've got those labeled, I can, of course, plug right into my formula: y sub 2 minus y sub 1 divided by x sub 2 minus x sub 1. So y sub 2 is going to be 2, and then I'm going to subtract a negative 2 divided by x sub 2, which is going to be negative 2, all over, or minus 0, x sub 1. Again, subtract a negative means that we're going to add that positive, so I'm going to get 4 over negative 2. So my slope is going to be negative 2. It doesn't matter if you would have flipped those around and called q sub 1 your x sub 2 and your y sub 2 and q sub 2 to be the other points. The key here is just make sure that your x and y values for the same point are where they need to be. So keep your 1's together and your 2's together just like they are in the formula. And I'm going to find the slope of p sub 1, p sub 2. Okay. Label x sub 2, y sub 2, x sub 1, y sub 1. Again, you can switch those around. It doesn't really matter which one you consider point 1 and point 2. But we plug into our slope formula. I get negative 1/2 minus 2 all over negative 3 minus 2. Negative 1/2 minus 2 is going to give me negative 2.5 or negative 5/2 all over negative 5. Then to simplify this, we just multiply by the reciprocal of our denominator, so negative 1/5. Okay, the reason we do that, this cross cancels here, the negatives go to a positive, and we're lucky here that this 5 and this 5 will cross cancel, so I end up with a slope of positive 1/2, because when you multiply the two negatives, you get that positive. So there's the slope of those two lines. Just some theorems here. You've got 4 points. And you got point 1, 2, 3, and 4 with their coordinates. If those points are on a non-vertical line, then you can find the slope from point 1 to point 2, and that's going to have the same slope from point 3 to point 4. You could go from point 2 to point 3 if you wanted, but what it's saying is any points on a line are going to have the same slope. Then the slope of a non-vertical line is the slope of the segment determined by any 2 points on the line, saying what I just kind of said. If you've got points on a line, the slope is going to be the same everywhere. And finally, theorem 2.4 here is going to talk about a different way to write the equation of a line. We talked about this last year. This right here is what we call point slope. So point slope form, where your h and your k values are going to come from some point on that line. So we could have used, maybe in the last example, the point 2, or 0, -2. M is still your slope. And x and y here are just going to be placeholders, just like they are in every other form of a line. Mx plus b, you leave the x and y alone. So maybe an example of a line would be y minus 3 is equal to 2 times x minus 4. Okay. The last thing I really want to draw your attention to, remember, these are both defined by subtraction. So if you see addition, then you are dealing with negative h and k values. So it'll be opposite of what it appears. So how are we going to use this to our advantage? I really like this form. I think it makes things go a little easier. So we're going to write the equation of a line with a slope of 7 that contains the points -2, 5. So you have that point slope form, y minus k is equal to m times x minus h. So plug in what we know. This is an x value of -2. This is a y value of 5. Y's go with y's, so I'm going to end up with y minus 5 is equal to slope, m, of 7 times x. And now I'm going to subtract a negative 2, so that's going to be x plus 2. So from here, that's perfectly acceptable answer for me. You don't have to simplify it anymore. You don't have to do any of the algebra. Just plug in what you know. So I like these pretty well. I think it makes problems, especially like this, go pretty slick. Then we're going to write the equation of the line that contains the point 1, 6 and negative 1, 2. So if we're going to do this, every time we find the equation of a line, we need to find our slope. So I'm going to label this x sub 1, y sub 1, and x sub 2, y sub 2. For real, no real particular reason. We're going to use our slope formula, y sub 2 minus y sub 1 over x sub 2 minus x sub 1. So I'm going to get 2 minus 6 divided by negative 1 minus 1. 2 minus 6 is going to give me a negative 4. Negative 1 minus 1 is going to give me a negative 2. So I end up with a slope of positive 2. Now, if I want to write the equation of the line, I'm going to use that point slope form again. It makes things nice for me. So y minus k is equal to m times x minus h. So I'm going to pick one of my points. For this one, I'm going to pick the point 1, 6. So I'm going to have y minus my y value of 6 is equal to my slope, which I just found to be 2 times x minus my x value, which is going to be 1. Okay, so there's one potential answer. But what if you pick the other one? Well, when you've got 2 points, you've got multiple points that you can choose from. One is not more right than the other. I will make sure that I list both possibilities if you run into this situation on homework or whatever. So if I use point Q, that changes the way my answer looks. So I'm going to have y minus my y value in this case, which is going to be 2, is going to be equal to the slope of 2 times x minus my x value. If I'm going to subtract a negative 1, I've got to add that negative 1. So both of these are going to say the same thing, even though they look different. Then the old favorite slope-intercept form, y equals mx plus b. Again, m is your slope, and b is your y-intercept. So if we try to find a line that has a y-intercept of negative 2 and an x-intercept of 6, we want to write the equation of the line in slope-intercept. So we don't have a place to put this x-intercept, but what we do know is that if it's an x-intercept, that means we're crossing the x-axis at 6, and we have a y value of 0. And with a y-intercept, we can do the same thing. We have an x value of 0 and a y value of negative 2. So we can use those 2 points to help us find that equation. So we'll find our slope, x sub 1, y sub 1, x sub 2, y sub 2. Again, really no reason why I do it in that particular order. It's just what I do. So slope, y sub 2 minus y sub 1 over x sub 2 minus x sub 1 is going to give me 0 minus a negative 2 divided by 6 minus 0. Again, we're going to add our positive since we're subtracting a negative to get a slope of 2 over 6, which is the same thing as 1/3. And now we'll plug into our slope-intercept form. We have our slope 1/3, so y equals 1/3 x. And we've got a y-intercept of negative 2, so I'm going to put minus 2. So there's where it is. Here's your homework, 2 through 30 even. We'll work on this today, and you guys will get some practice with it tomorrow as well. So let me know if you have questions. I will check my email throughout the day so that you guys can ask me whatever you need to know. You guys can also work together and ask each other questions too.